Hello and welcome to this Science mini-masterclass video. This is part 6 of my calculations in chemistry series, with this session focusing on advanced molar calculations, specifically how to deduce the formula for a product and how to deduce the balanced symbol equation based on the molar ratio of reactants and or products. Please note this is for higher tier students only, however it is applicable no matter what exam board you are studying for. We will of course require a calculator for this session. Throughout the course of the exam questions we look at, there'll be plenty of hints, tips and common errors to watch out for based on my many years of leadership in science experience and examining experience. Let's get cracking. Now, the two golden triangles, as I call them, for quantitative chemistry, shown on the screen there to you. If you've not seen these before or you're not familiar with them, please check out my previous videos on concentration calculations, the basics of moles, and my previous session on advanced molar calculations as well. If you do not know these off by heart already, I strongly recommend getting them drawn out on a coloured bit of paper, stuck up on your bedroom wall, so you're seeing them twice a day, every day. If you do that, I guarantee you will have memorised them by the time you come to sit your exams, because after all, there is no chemistry formula sheet for your GCSE exam papers. Right. I'm going to do this one then. I'm told that iron reacts with oxygen to produce iron oxide. I've been given the moles of iron and the moles of oxygen gas. I've been asked to deduce the formula of the iron oxide produced and the balanced symbol equation. Now that's my information I've been given about the moles of iron and the moles of oxygen. I've obviously underlined that. And I've clearly been given the molecular formula for oxygen, being a molecule, as well for a reason. This is worth 4 marks. To begin with then, just to help build my answer, I've decided to write out the word equation for this, so I can actually see and picture what's actually going on here in this reaction. Now, step 1 is to extract that information from the question and list the moles of iron versus the moles of O2. No marks so far. What I'm then going to do is work out the molar ratio of iron, Fe, to O2 by dividing each of the moles by the smallest of the two. We've used this skill previously in the likes of calculating empirical formulas and so on. Now this gives me a 1.5 to 1 mole ratio. Now that's not in a whole number format, okay? So what I then have to do is convert 1.5 to 1 into 3 to 2. That's the simplest whole number ratio of Fe to O2. However, if I'm looking at the formula for iron oxide, then I need to consider how many atoms of iron are bonded to how many atoms of oxygen. So a 3 to 2 ratio of Fe to O2 is a 3 to 4 ratio of Fe to O, because there are 2 atoms of oxygen per mole, or per molecule, of O2. So I've doubled the number of moles for my O2 to give me the number of moles of O. There is my formula for the iron oxide. What I've then done is use that to deduce the balanced symbol equation, firstly by putting my Fe3O4 as my product and then scaling back to my reactants using the question again to support me. Iron plus oxygen, they're my only 2 reactants, and to balance this I would need 3 atoms of iron to 2 molecules of O2 to produce 1 mole of Fe3O4. I get 1 mark for firstly deducing my molar ratio, second mark for then getting a whole number molar ratio of Fe to O, third mark for the formula of iron oxide, and fourth mark for the balanced symbol equation. One more that I'm going to tackle before I let you have a go at one yourself. This scenario does not give me the moles of the reactants. I have reacting masses instead. And you will see on the right hand side my massive arm or massive Mr. Mole, however you want to remember it, triangle equation, golden triangle equation that I'm going to need to use as part of this question. So I've been asked to deduce the balanced symbol equation for the reaction of aluminium with chlorine to produce aluminium chloride. I've been given my relative atomic masses here. The first step, again, up to you. I recommend, just to help build your answer around the word equation so we can see exactly what's going on here, I've written out the word equation for the reaction of aluminium with chlorine to produce aluminium chloride. Not going to get a mark, but it helps my line of thought. Next step. Up to you if you want to draw a table like this or just do it as lists. It helps the examiner mark your answer if it's nice and clear, though, in the likes of a table. Nice neat lines though aren't required with the use of a ruler. I've entered my known values for the actual masses from the question and those relative masses. Please note I've obviously calculated the relative formula mass of a molecule of chlorine by multiplying the relative atomic mass by 2 to give me 71. Next step, calculate my moles. Mass divided by relative mass. 10.8 divided by 27 gives me 0.4 moles of aluminium. I do exactly the same to get my moles of Cl2, 0.6 moles. There's a mark. My molar ratio then, well, dividing both by the smallest of the two, with 0.4 being the smallest, gives me a 1 to 1.5 molar ratio. Now that's not in whole number format yet, okay? So I'm then going to convert that to whole numbers to give me a 2 to 3 molar ratio. I've just doubled both of those. And that's going to get me my second mark. Next job is to deduce the balanced symbol equation. Now there's 2 marks up for grabs for this, and I'll explain where those 2 marks come from. The first mark is for using my 2 to 3 molar ratio of Al to CO2 to write out my reactants as 2 moles of aluminium to 3 moles of CO2. The second mark is relating to my aluminium chloride. Don't forget we were given the molecular formula for aluminium chloride, AlCl3, in the question, and then all I've had to do is balance this in the usual format by looking at how many atoms of aluminium and how many atoms of chlorine I have in my reactants and making sure that I've got the same in my one and only product, aluminium chloride. 2 atoms of aluminium and 2 times 3 is 6 atoms of chlorine. Balancing done. Right then, one for you to have a go at. This is worth 4 marks, so you should be aiming to spend no more than 4 minutes on this question. Please pause the video and I'll review in a moment. Okay. Whether or not you've decided to construct a table like this, that's entirely up to you. However, I need to clearly see that you've got the moles of FeO based on the actual mass and the relative mass, and the moles of Al, aluminium, based on the actual mass and the relative mass. That gives us 0.3 and 0.2 for 1 mark. We then need a molar ratio by dividing both by the smallest of the 2, so they've both been divided by 0.2 to give a 1.5 to 1 molar ratio, but that's not in whole number format, so that in this case is a 3 to 2 molar ratio of FeO to Al. You get a mark for that being shown clearly somewhere in your answer. Next step, producing the balanced symbol equation. If you've got this bit right, which we should have done based on the molar ratio of FeO to Al and the basics of seeing, well, if we've got 3 iron atoms, then we would have to have 3 iron atoms in our product as well. And the 4th mark is for getting the formula of aluminium oxide correct. Again, balancing this in the usual format by looking at the number of atoms of each of those elements in our reactants and getting the same in our products. Okay. Right, that's a wrap. Mission complete. Chemistry part 6 done and dusted. That's advanced molar calculations complete. If you found that useful, please hit the like button, and for more Science Mini Masterclasses, please do subscribe to my channel. Join me again for part 7 of calculations in chemistry. I'll see you in the next one.